Hey, this is Kyle from essentialdeveloper.com. In the previous episode, we created a clean architecture for our logging feature, and we have separated business logic from frameworks and presentation and UI. We also separated UI from presentation so we can have different applications reusing everything behind the UI layer. We also made sure to keep analytics outside the implementation of UI presentation or business logic so we can easily introduce new ways of collecting this data, which makes it much more flexible. And since we separated everything, we need to combine the implementations at some point, and we defined a main layer where we're going to have our factories, flows, composing those implementations together. Great. So one of the most asked questions was, how can we compose implementations of a protocol like we have defined here in our architecture? So for example, the logging use case output is implemented by the presenter, and that's the natural flow. The presenter can get the logged in user or a failure and map it to a nice view model and pass it to the view controller so it can be rendered on the screen. But we also made our analytics wrappers implement the protocol so we can very easily collect and log this data with our analytics frameworks. So how can we have multiple implementations of a protocol composed together? Well, that's what we're going to see today. So let's go. So I have an empty project here. Let me create our first class. Let's call it login use case. And if we follow the diagram, we're going to have our use case, and it has a method login with name and password. And when it has a result, it's going to delegate it through a protocol so the implementations of it can decide what to do. Great. And how does this protocol look like? Well, if we follow our diagram, use case output, and it has two functions. Login succeeded, and it passes the user that was created. But for this example, let's omit this type. And it also has a login failed method. Great. And one of the potential implementers of this protocol is the presenter, or a view controller, or a view model. Depends how you structure your UI and presentation layer. In our case, we have a presenter, so let me create a login presenter here. And let's make it conform to our login use case output protocol. So when we get this message, we're going to delegate it to the view controller. And if it fails, it's going to create an error view model and pass it to the view controller. But we're not going to implement these functions today. Our goal is to show how to compose those objects. Great. That's pretty much what we want. But we also have other objects that implement a protocol. So let's create some examples here. You can have a crash analytics logging tracker, let's say. Could be a struct if you want. Send error to crash analytics. If succeeded, we can also log these into crash analytics. Great. And let's say we also use Firebase analytics in our project. So send error to Firebase, send logging event to Firebase. Great. So now we have three objects that implement the output protocol. So the easiest way to compose this, and sadly is the most used, is to have all the concrete implementations inside the use case or the view controller or whatever object is responsible for logging those analytics events. So we would have something like crash analytics tracker, Firebase tracker, and we can have our presenter then. Cool. Then we will need an initializer. So this implementation does not conform to our clean architecture defined here, because the use case now knows about concrete types. So all those errors are inverted now. The use case points to analytics, implementations, and to the presenter, instead of the login presenter, depending on the business logic. So how this would work would be something like crashlist tracker.logging succeeded, firebase tracker.logging succeeded, and login presenter.logging succeeded. And then every time there is a new tracker or a new requirement, we have to add another dependency here, and it makes it much harder to create this object. And normally people just start removing those explicit dependencies and start using singletons, so it would be something like tracker.shared.logging succeeded, and at some point we lose track of all the dependencies, everything is implicit, and it doesn't conform to the good traits we talked about in the previous video of making things scalable, easy to test, easy to maintain. So one way to remove the dependencies from the concrete types would be to just change the types to the protocol. So now the errors are correct again, the dependencies are inverted, so the business logic has no idea that properties exist, and the login presenter as well. But that's a lie, because to start this login use case, we need to pass 3 types. So this doesn't solve the problem of having to remove something or add a new feature without having to change this class. Because if we follow the open-close principle, we should be able to extend the behavior without having to change the class. And we are trying to use composition rather than inheritance here. So I'm even going to make this final class, so there is no way to subclass it. So if we're trying to make this very flexible, so every time there's a new tracker or I have to remove a tracker, I don't have to change this class. The way of doing this is to just have outputs as an array. And I can have outputs dot for each, and we execute whatever method we want. So it would be something like if success, else logging failed. So now we remove the dependencies from types, and we have also removed the dependencies of how many outputs can I have. So I have a generic array of protocols, and I just delegate the message to all of them. But this makes the design of my use case a bit weird, because I just want to send a message. I don't want to have to iterate and send a message. It's too much responsibility. So what I can do is have just an output and send a message to it. This is the implementation I want here. Simple as that. And of course, this success is going to be decided by talking to an API. This is just pseudocode. So how can I have this login use case sending a message to one type, but then getting it delegated to all of the ones I want? Well, if we look at our diagram, in main, I set up a compose login use case delegate, or whatever we want to call it, that is responsible for composing all the objects together. Instead of making the composition inside the use case, I explicitly set this responsibility to main, because main is responsible for factoring objects. Main is responsible for composing and setting up the application in my object graph in a way that everything is composed as it should be, so I can have clean code in all my layers. I never create objects, or I never need to know about composition in the business logic side, or presentation, or UI. So how would the implementation of this object look like? Well, let's start with tests. So we're gonna have a login use case output composer tests. So we're gonna create our type. Let me open in a second window here. Great. What should be your first test? I always like to start with the error case. So let's say composing 0 outputs does not crash. I guess this is a valid scenario. So let's say login succeeded and logging failed. And of course, we don't implement a protocol yet, so let's do this. The composer implements the protocol. Okay, it works. So second test, composing one output, delegates, succeeded, message. Great. So if we create an output, and we're gonna have to have an output spy or something that can capture those calls. Let's quickly create one. And let's capture the call count. And we increment the value every time this is called. And this object is just used for testing. Great. Now I can create my SUT by passing the output. We have a build error, so let's fix it by creating an initializer that receives outputs. And that's an array of logging use case outputs. Great. So I'm going to call logging succeeded, and I want to make sure that my output succeeded call count is 1, and the failed count should be 0. Great. So this broke our first test. Let's pass an empty array. Cool. Failing test. Let's make it pass. Let's create our outputs property. Now let's just do the minimum to make this pass, and let's say outputs.first logging succeeded. Run the test again, and it passes. Great. Now let's create the one for the failed case. Let's see a failing test. Great. Run again. It passes. Awesome. Now I want to make sure that composing multiple outputs delegates succeeded message. So let me create a second output. And I want to make sure both of them received the message, and they should fail. Great. So now I can have my for each implementation, or whatever implementation you want to have. Let's run the test, and it passes. So let's do the same thing for the failed case. Awesome. Now let's make it pass. Great, it passes. So anything to refactor here? I don't think so. Anything here? No, I think it looks good. But since we are testing this multiple outputs, I don't think we need the case for one output only. I think it's implied it works. We can debate this, but I'm going to get rid of it. There it is. Great. That's all. Now we have a composer, and our use case is very clean. It doesn't need to know about this composition. It doesn't need to know about any other external layer. So this solves our problem of composing those objects. There are other ways we can implement this. Instead of using an array protocols, we can also pass the concrete types. And then you can have the type system checking the correctness of your composition. I like the generic way of doing this with protocols, but it depends what you're trying to achieve. Another way to ensure that you have the right types in your composer is to have tests. And who's going to use the composer? A factory. So, okay, as a bonus, let's write a factory object. Of course, let's start with a test. Let's call it login use case factory tests. So let's create our login use case factory. So let's create our use case. Something like make use case, or create use case, or create login use case. And let's say xc assert true use case dot output is a composer. Okay, let's implement the make use case function. And this returns a login use case. Great. So let's return our login use case with an output. Let's use a login presenter for now. just so I can see a failing test. And there it is. We're not getting the right type. Now we can have a composer with nothing inside, and the test should pass. Great. So let's capture this output in a variable now. And let's cast it. And let's change this test to not nil. Just to make sure we have an output. Great. Now we can test our output.outputs count should be 3, because I want to make sure I have the login presenter, the Crashlytics tracker, and the Firebase tracker. Great. And I think I should rename this to composer. Cool. Let's run this, and it's gonna fail. Boom, it fails. So the minimum to make this pass, let's just use some composers here. And of course you can compose composers. I don't know why you would do that, but you can. There it is. Great. I want to make sure that I have my presenter, my Crashlytics, and the Firebase tracker. And how can I do this? If we filter the outputs, we should have one login presenter. And it fails. So let's have our login presenter here. Great. Now let's have a test for Crashlytics login tracker. Great. Last one, the Firebase Lytics tracker. Great. Let's give this a name. Let's say created use case has composed outputs. Awesome. We could also break this down into separate tests. I think they are very related, so I'm okay with this being in one test, but we can do some refactorings. We can create a private extension. Say count of type t. This returns an integer. Well, let's define the type. Now we can return the count. And of course I don't need this, and I need the type. Let's run the test and the pass. Great. So this is a different way you can guarantee the composition is right, and we have tests for everything. Now the last thing, let's add those things to folders, just so we can see the separation of concerns here. There it is. Our business logic has the use case, and it has no dependencies, just like in our diagram. The presenter implements the use case output, so it depends on the business logic. The analytics also depends on the business logic. They also implement the output, and they're going to talk to frameworks. And in main, we have our composers and our factories. So in our test target, we can also group the files and have main. And as we have implementations for these types, of course we're going to add tests for it as well and separate it properly. And at some point you can move those folders to separate projects and break it down in modules and Swift frameworks and reuse it across your applications. It's up to you. And this is a way of composing types by removing this responsibility from the object and moving it to main. And this is our goal. We want to have this flexible, maintainable, and scalable architecture that can accommodate the business needs, that is easy to test. It increases your estimation accuracy. You can develop this in parallel. You can have developers writing analytic wrappers. You can have other developers writing a presentation layer. You can have like two teams implementing different UIs. And you can also change the UI presentation without affecting the business logic. You can implement things. You can add new frameworks, remove frameworks, and all those changes are fairly easy to do. It's easier to measure the cost, the impact is very low, and you can keep developing things fast throughout the development cycle. And of course, you could also compose functions. If you don't want to use classes, you can create a compose function that starts with an array of functions. In this case, let's say it gets a generic parameter and returns void, and this function returns another function of type t to void. So you can just return a function that runs all the functions inside the array with the given value. And this is how you would compose functions with generic types as well. Very easy to do, so it really depends what you're trying to achieve here. Alright, so that's it for this episode. I hope you enjoyed and learned something today. Thanks for watching. Bye!